Hello there, it's time for another basic science lesson, and today we'll be looking at the topic chemical formula. Now, moving along, the objectives of this lesson is to help learners to define and describe chemical formula, state the chemical formula of some molecules of common elements and compounds, describe the formula of ionic compounds, and finally state the steps for writing the chemical formula of ionic compound. Now, moving along, what is chemical formula? A chemical formula is the representation of a molecule of a substance, whether it be an element or a compound, by using symbols and numbers. Now, the symbols are represented by letters, while the numerals represent the number of atoms in the molecule of an element or compound. Now, looking at this example, this is a chemical formula. This is a chemical formula, and this is a chemical formula for water. This is a chemical formula for water. As you can see, water, one molecule of water is made up of two different elements, which symbols are represented. Hydrogen, H representing hydrogen, while this capital letter O represents oxygen. Now, this subscript here shows us that in one molecule of water you have two atoms of hydrogen and one oxygen atom. So as you can see, there are two hydrogen atoms and one oxygen atom. The one behind the oxygen is imaginary. So how many atoms are there in total? You have two hydrogen atoms right here plus one oxygen atom, so which gives us three atoms in total. So this is an example of a chemical formula of one molecule of water. Now, moving along, we have examples of chemical formula of molecules of elements and compounds. Now, this is the chemical formula of certain diatomic molecules, elements that occur as diatomic molecules. We have hydrogen. An hydrogen molecule exists. This is the basic unit. So you have subscript 2 here, which indicates that in one molecule of hydrogen gas, you have two hydrogen atoms. The same with nitrogen. You have N subscript 2. Oxygen, we have O subscript 2. Fluorine, we have F subscript 2. Chlorine, Cl subscript 2. Bromine, Br subscript 2. And iodine, I subscript 2. So it shows you that you have two atoms in one molecule of these elements. Now, in the case of compounds, we have chemical formulas of compounds like water, which we saw in the previous slide. It's H2, H subscript 2O, which shows us that we have in one molecule of water we have two hydrogen atoms and one oxygen atom. In the case of glucose, glucose is made up of three different elements: carbon, hydrogen, and oxygen. This subscript shows that in one molecule of glucose you have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Now, what we have here is salt, sodium chloride. We have 1 atom of sodium and 1 atom of chlorine. In ethanol, which is also made up of carbon, hydrogen, and oxygen, you have 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom in one molecule of ethanol. In the case of ammonia, we have nitrogen and hydrogen. The ratio of hydrogen to nitrogen here is 3:1. So you have 3 hydrogen atoms and 3 hydrogen atoms and 1 nitrogen atom. Sulfuric acid, which is also known as tetraoxosulfuric acid, has 3 different elements that make up that form the chemical formula. You have hydrogen, sulfur, and oxygen. You have 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atom. We have methane, which is CH4. We have sucrose, which is a sugar. We have 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen. Now, moving along, we are going to be looking at formula of ionic compounds. Now, when metals lose electrons, they form positively charged ions called cations. The more electrons lost, the more the positive charge. For example, we have sodium atom and sodium ion here, which means that it has lost one electron in its outermost shell. So which gives it its positive charge. You can see you have +1 right here, which means it has lost 1 electron. Calcium ion here, which has a charge of 2, means it has lost 2 electrons. Aluminium here, which has a positive charge 3, has lost 3 electrons. And lead here has lost what? Has lost also 3 electrons, not 4, 3. You see, so when non-metals gain electrons, they form negatively charged ions called anions. The more the electrons gained, the greater the negative charge. So you have phosphorus ion here, sulfur ion, and chloride ion, which means that phosphorus ion has gained 3 electrons, sulfur ion has gained 2 electrons, chlorine ion has gained 1 electron. Now this is important because the formula of ionic compound is derived as writing the symbol of the cation before the anion. For instance, the chemical formula for sodium chloride, which is an ionic compound, is written as sodium ion plus chloride ion, which will give us sodium chloride. So you have examples of ionic compound formula. So you can see the cation and the anion here. So once they join together, it will give us magnesium chloride, as we have it here. You have rubidium and sulfur, which will give us rubidium sulfide. We have aluminium and bromine ions, which will give us aluminium bromide, and it goes on and on and on like that. Now we are moving on to steps to writing chemical formula of ionic compounds. Now what we have here are 5 steps to writing the chemical formula of ionic compound. Number 1, you need to know the elements that make up the compound, and sometimes the radicals as well. We'll talk about radicals later. Know the symbols of the elements and radicals. Know their combining power or valencies. Exchange their valencies or charges, and finally write the chemical formula. Now I'm going to put even these steps to work using a particular example. Now what we have here is we want to write the chemical formula of this ionic compound, aluminum sulfate. Now looking at step number 1, it says know the elements that make up the compound and sometimes the radicals. Now the elements that make up this compound, you have aluminum and the radical sulfate. Now what is a radical? A radical is a group of atoms that carry a charge. In this case, the radical is sulfate. Now number 2, we need to know the symbols of the elements and radical. Now this is the symbol of aluminum right here, Al, and the symbol and the formula for the radical is SO4. The radical is made up of sulfur, oxygen, and the oxygen, we have 4 atoms of oxygen, which is shown in the subscript 4 that we have right here. Now number 3, we need to know their combining power. The combining power of valency of aluminum is plus 3, while the combining power for sulfate ion is -2. Now as you have here, we need to exchange their valencies. Now from what we have here, we have the aluminum that carries the +3 charge, and sulfate ion that carries sulfate radical or ion that carries -2. So what we need to do is exchange the valencies or the charges. So as you can see right here, the -2, which is for the sulfate radical, goes to aluminum, while the +3 goes to the sulfate. Now we have the final formula right here. Now if you are wondering why is it that we don't have the subscript 3 right here, why is it in bracket? The sulfate formula having the 3 right here. Well, this one shows that everything that is inside the bracket carries the 3, or the 3 reflects on everything that is inside this bracket. In other words, in this bracket, if we remove this bracket, this sulfate or this sulfur element here is 3. We have 3 atoms of sulfur in this whole aluminum sulfate compound, and the number of oxygen here, which we have 4 right here, 4 times 3 will make what? 12. In other words, this sulfate ion, we have 3 of it against 2 aluminum atoms. So if you are to ask what is the total number of atoms that we have in this aluminum sulfate molecule right here, it means we have 2 aluminum atoms, we have 3 sulfate atoms, and 12 oxygen atoms, because we have 4 oxygen atoms here in 3 places, which makes it 12. So aluminum in 2 places here, sulfur here is 3, and oxygen is 12, making how many atoms in total? 17 atoms. So that is, we have 17 atoms making up aluminum sulfate. Now moving along, we have examples of various chemical formula of ionic compounds that you have right here. So you have sodium chloride, which has one sodium here has 1 charge, and chloride here has 1 charge. So putting them together, normally we are supposed to write Na1 Cl1, but because they have the same number of valencies, so we don't write it right here. Just like you have magnesium oxide here, so they both have 2 plus 2 and minus 2 charges, or their combining power is 2 and 2. So putting them here, there's no need for us to put magnesium subscript 2 here and oxygen subscript 2 here. So all we just need to do is, because they have the same ratio, we just leave them like that without writing the 2 or 1 1. And it goes on and on for the various examples that you have here. So I want to pause this video and examine the various ionic compounds one after the other to have a full understanding. Now it's the same thing that we have here too, various examples that we have here for ionic compounds, how to write them. So in case you are given maybe some to write, this is how you do them, and this shows you how you can go about writing the chemical formula of ionic. Now moving along, we have the symbol of simple ions. So you have ammonium ion, you have the formula right here. Copper ion, you have the formula right here. Lithium, you have the formula. Those that carry plus 1 charge, those that carry plus 2 charge. Barium, calcium, copper 2, we have them here. Aluminium ion carries the charge of plus 3, while lead and tin carry the charge of plus 4. We have anions here, that is negative ions, those that carry minus 1 charge, we have them here. Both atoms and radicals, we have the one that carry minus 2 charge, we have the one that carry minus 3 charge. This will help you in writing the chemical formula of ionic compound. Now we have come to the end of our lesson for today. Before we go, let's take a quick look at the summary. A chemical formula is a representation of a molecule of a substance, whether it be an element or a compound, by using symbols and numbers. Now the symbols are represented by letters, while the numerals represent the number of atoms in the molecule of element or compound. Now the formula of an ionic compound is derived at writing the symbol of the cation before the anion. Now before we go, you need to pause this video and attempt the questions in this assessment to see how much of the lessons that you have understood or learned personally. And before I go, I would like you to please like, share this video, and also subscribe. And I'll see you again in the next lesson.